All right, we are going live. What's up, everybody? And welcome to live stream number 109. All right, this will be the official last live stream of 2021. Next week, we'll be having a Christmas concert on Tuesday. You are all invited. The information will be up soon, very soon about that. So by tomorrow, we'll have some different artists. And we also have in the presence today another artist who's joining us from Italy. As you can see, he has an amplifier behind him. And I knew that you were an AC/DC fan because the last time we had you on doing the first part of this live stream, today we're doing the second part about benchmarking Postgres workloads on Kubernetes. But what's always cool about the Data on Kubernetes community, having done 110 live streams, 109, is that we've met a lot of different people, lots of different backgrounds. And so tell me, well, first of all, tell us, some folks who don't know who you are, but then tell us a little bit more about your musical background, how you got started playing guitar.
Yeah, you know how I started playing guitar is actually after watching Back to the Future. And
because playing Chuck Berry.
Exactly. I wanted to be, Marty McFly,
I love it.
Yeah, that scene was, I used to play piano as well, so when I was 6, I played the piano for 3 years. And then I wanted to be a football player, and I failed. And then I resumed playing the guitar about 15 years ago. Okay. The electric guitar, and I'm a big fan of blues and rock. Yeah.
Okay. And you've been in a band. Obviously, COVID has disrupted that. But what's the name of your band?
The name of the band was the Wonderlands, because the name of the singer was Alice Ellis. So we were the Wonderland, and we were playing kind of soul rock style, but in the area, in the area between Prato, Pistoia, and Florence. And Pistoia is a renowned city for blues in Italy.
Okay.
So, there's a big blues community.
Very, very good. Is there any particular reason how that came about? There's like a record store or a festival or a concert? Or
there's a festival. There's a Pistoia Blues is a quite renowned blues festival in Italy. Yeah.
Okay, very, very good. That's curious, but it's nice to learn, alongside, getting databases on Kubernetes, and we can learn about blues festivals in Italy. That's also good. It is the holiday season. It's no coincidence that I'm wearing this gorgeous sweater, but, it's all about giving. And so sharing information, sharing is caring. That's good. That being said, though, today is part 2 for what we did a few months ago regarding benchmarking workloads regarding Postgres on Kubernetes. So perhaps for the folks that maybe haven't seen the first one, go out and watch it. I'll drop the link in the chat so you can find it easily. But if you can maybe just give us a little bit of context and background about how this idea got started.
Yeah. Okay. And in the slides, I'm going to do a quick recap of.
So if you want, you can start sharing your slides directly if you want.
Oh,
whatever you prefer.
But,
okay.
Yeah, I actually like to mention how it all started.
Okay.
I'm actually glad to be here because of the importance of the data on Kubernetes community. I think there's still, even for example, even yesterday I was talking about a customer engagement, and then there's still this, uncertainty about using Postgres or databases in general in Kubernetes, and so that's the kind of era I think of IT we are currently living in. Okay, and I'm sure the future will be green for all of us in this area. It's just a matter of time. And so I think the importance of benchmarking is even greater here in this phase, because people need to be assured about running stateful workloads in Kubernetes. And I think the best way to become confident about running, for example, Postgres in a Kubernetes environment is to try and break it. So try and push the limits, see how it can perform. And again, there's no one size fits all kind of rule. You need to kind of benchmark and adapt the architecture based on your goals and your also budget and things like that. Okay, so and so the good thing is about learning a methodology and try to understand how we can tune the system for our organization. Okay, so thanks again for the work that you guys are doing with this community.
Much appreciated. No, it's really nice to hear that from someone who obviously has plenty of experience and has seen, and like you said, customer facing as well too, the challenges, the doubts, the reluctance. Does this really make sense? That's why we've done 109 live streams. And that's also why we have a research report. And I'm happy to drop that in the chat too, is that we did the research, interviewing over 500 organizations so that we don't just sound like the crazy people saying that this is a great idea. We want to have actual data showing why, making the case for this. But with each conversation we have, we feel more and more confident about that. And it's great to have folks like, EDB on board with us to make those cases stronger. So also mutually appreciated.
Yeah. Thanks. So I don't know if you want to, I can start.
Do it. Go for it.
Sharing the slides if I'm capable of doing that.
That's so funny is that we're always talking about these advanced technologies, but things like Zoom are also very complex. Even though we now have quite a bit of experience with it, there's always surprises. That being said, folks, as usual, get your questions in the YouTube chat. If not as well, easy to continue the conversation in Slack. We have a dedicated database channel. You can post questions there. You can ask Gabriele, also some other people from EDB that are in our Slack. Very friendly. I'm happy to interact with you. So just remember, we're doing this so that we can get these conversations going.
Okay, I don't know if you can see my screen. Okay, so hang on. I'll actually move it. Sorry, I'll try and move it here. Otherwise, I can't. Can you? Sorry, I think I lost.
Okay. Yeah, you should be okay now.
I don't know. I can't see it anymore.
That's okay. Yeah, I don't see your screen now. So you want to probably go ahead and share it again.
1 second. Okay. Let's see.
It's all good.
No, I can't see this. I don't know. 1 second.
Not a problem. Not a problem. While we're getting that set up, we interestingly had a YouTube chat troll that I had to remove. So there's plenty of action going on. We still haven't jumped into the presentation fully. That being said, though, I was talking about the research report, and we're never going to get tired of talking about the research report. Okay. It's very useful, and there's lots of fun stuff here. So I'm just going to drop the link in the chat right now. So if you want to take a look at that, there's lots and lots of good info there. Let's see. Now I can see your screen again.
Okay,
you're all good.
Good.
Yeah,
I apologize for that.
It's all good, man. No worries.
Okay, so briefly, I'm apart from trying to play the guitar, I'm also really happy to be part of EDB, where I am the vice president of Cloud Native. But I've been using Postgres for many, many years now, so over 20 years. And I've been a member of the community for more than 15. And I'm also one of the founders of Postgres Europe. I previously, from joining EDB, I was one of the co-founders of Second Quadrant, where I was the head of global support. And I also started the Kubernetes work that was taken over by EDB. About 10 years ago, I also started to develop an open source tool for managing backups and recovery in Postgres called Barman. I'm also a big fan of DevOps, so always pleasure to talk about DevOps, Lean, Agile methodologies, and leadership as well. So I'll tell you a bit about EDB. So our mission in Kubernetes is to actually bring Postgres to Kubernetes. That's the goal of my kind of team at EDB. But EDB has been contributing to Postgres for over 15 years. And if you're using Postgres, it's also thanks to a few companies like EDB and previously Second Quadrant, where I was working. For example, in Postgres 14, we've had 32 contributors, and this includes 7 code committers and 3 co-members. So we are considered, one of the major sponsors of the Postgres project, and we are also a Kubernetes certified service provider and a silver member of CNCF and the Linux Foundation. We actually were the first company to become a KCSP that is vertically focused on Postgres. And we are also a platinum funding sponsor of the Data on Kubernetes community, and we're really happy to be in this community, trying to, as I said, build awareness about using databases in Kubernetes. So as I anticipated, I'll be going over some of the key takeaways of the webinar we ran with Francesco Canovai about 6 months ago. Then I'll quickly try and summarize the life of a Postgres transaction and how this can impact when we benchmark. Okay, so then propose some of the recommended architectures for Postgres in Kubernetes and describe the methodology that we are currently using and developing to benchmark Postgres in Kubernetes.
And only one thing to mention about that, because there is a very high standard for this part 2. In part 1, Francesco arrived a little bit late to the live stream because he had recently had a tooth removed.
Exactly.
And he still did it, which was date on Kubernetes community history. We've since then had some other impressive things, but we haven't had anybody show up with a missing tooth. So I really respect him for that.
And he's a karate instructor, so.
And normally he's knocking other people's teeth out. This time it was his turn. Anyway, though, keep going.
Yeah, so again, this is the link to that webinar. I had shorter hair and wearing the AC/DC shirt. Now it's winter, so I'm wearing warmer jump. Anyway, in that occasion, we talked about why using Kubernetes, why using Postgres. Okay, so I was able to focus on the concept of cloud native, the meaning of cloud native. So, and I was able to explain my view on that concept, and that it's specifically more than tools. So we usually refer to cloud native as Kubernetes, so as the tool Kubernetes, but it's much more than that. So it's not only patterns or architecture. So, for example, microservices or the operator pattern, if you want to, bring systems into Kubernetes. But it's mostly about principles, values, and the culture. So I still believe that without this brain and engine and methodologies like DevOps, Lean, Agile that I have, developed in the last 15, 20 years, there would not be this cloud native movement. Okay, so at least it won't be as important as it is now. So it's all about understanding the goals and the whys we are doing things in a certain way. And cloud native and Kubernetes are now the expression of this mindset. Okay. And as we all know, and you were mentioning that before, Bart, there's been this report driven by the Data on Kubernetes community. There's the link there. And in this report, we clearly see how stateful workloads are becoming more popular among users. And this includes databases. So the main reasons: storage classes, support for local persistent volumes, and probably the operator pattern that has taken a lot of interest in these years. Then we went over Postgres, when we talk about Postgres, we have to think that it actually started in the 80s as a research project created by Michael Stonebreaker, who's one of the greatest minds in the database technology discipline. Okay, and but then it was restarted in the mid 90s. So we are talking about 25 years of, as I call it, evolutionary innovation. So innovation, one bit at a time. So building on top of what we built the year before. And Postgres has this development life cycle that lasts 1 year. And so every year, usually in autumn, there's a new major release of Postgres. And usually I like to refer to Postgres with this question is what Linux is for operating systems, Postgres is for databases. It was elected database of the year in 2017, 18, and 2020 by dbengines.com. And some of the main features are native stream replication, which is one of the reasons why I suggest, for example, to rely on these rather than file system level replication for Postgres. Online continuous backup, declarative partitioning, parallel queries, JSON support, PostGIS support, AC transactions, and so on. I mean, the list is infinite pretty much. Going back to replication, we support both physical and logical replication, and synchronous and asynchronous, and also cascading. So in 6 months ago, we talked about benchmarking the storage. So the storage is the most critical component in a system where a database runs. And we explained what to look for: sequential writes, fsync, random writes, random reads, sequential reads, and where they fit. Okay, I won't be covering storage benchmarking today. Please refer to the previous webinar and Francesco explaining what he did in that area. Also, there's CMP Bench, which was introduced back then, that you can use if you want to benchmark using FIO. Then we talked about benchmarking the database, in particular selecting depending on the workloads you're aiming for. So in-memory databases, OLTP, OLAP. And initially our activity was focused on funding the TPS metric, the transaction per second metric, on large OLTP workloads. When I mean large, I mean that the database size cannot fit the RAM of the system. Otherwise, it's primarily an in-memory database. And in that occasion, we focus primarily on pgbench. So what we learn is that we need to know the storage because we need to trust the storage. Okay, so always make sure to benchmark the storage before we go in production and before we test the database. It's useless to test a database if we don't know how the storage performs, because the storage can be your bottleneck. Remember that if your storage is low, your database will be always slow. So again, please look back to that webinar and understand how to use how we use CMP Bench in that occasion and FIO. So first, I want to provide a quick overview, a simplified view of how a transaction is handled by Postgres. And I want to apologize to all the Postgres experts because obviously Postgres internals are more complex than these. I tried to simplify this whole workflow to clarify the concepts I want to explore today. So yeah, another brick in the wall, but the brick in this case is a transaction that fits into the wall. So we've got the shared buffers. That's how Postgres calls them. It's the Postgres cache, okay, and that fits in shared memory. Okay, because Postgres is a multi-process system, so it uses shared memory. Pages in Postgres are 8 kilobytes by default, and they rely on usually they rely on disk especially when the database is shut down. Okay, so we call it pgdata. Pgdata is the directory where data files exist. Consider Postgres is running. There's a new backend. A backend is a process that manages a connection with a client. So this backend starts a transaction and maybe wants to read this page that is on disk. So what Postgres does is actually to read the page from disk, put it in the cache, and serve it to the backend. And this is where we observe, for example, random reads or optimized sequential scans in case we are reading, a large chunk of a table sequentially. Okay, so this is where, for example, random reads or sequential reads of a storage need to be measured. Okay, then maybe this backend make a change to a record. So we're actually changing the content of a page in the buffers, and we actually say that the page is now dirty. Okay, so the page is dirty, so there's actually a disalignment between what's in the cache and what's on disk. Okay, but that's fine because actually Postgres, what it does, it immediately writes this information in the transaction log. Okay, the transaction log is the write-ahead log, and it's organized in WAL file segments, which are files usually 16 megabytes inside. And they are sequentially written, and they are continuously f-synced. So that's why it's important to measure sequential writes when we work with Postgres. And also we make sure that we are able to f-sync efficiently and effectively. Okay, you know that, for example, between the shared buffers and the PG data, there's also the operating system cache. So we need to make sure that with f-sync, we bypass that. But also, if we are running in a virtualized environment, for example, there's the cache between the the hypervisor and the underlying operating system. So in that case, we also need to make sure that we bypass that. And in case there's also a cache for storage, as there should be, we need to make sure that we also bypass there, or if there's a the cache that there's a battery that can write data on disk in case power goes down. Okay, anyway, this is all stuff that applies also in the Kubernetes space. Okay, so this was true in bare metal installations and in VMs installations, and it's basically the same in Kubernetes. So asynchronously, and this activity happens regularly, the database cache is flushed on disk. So the dirty pages are written on disk. This is called checkpoints. Okay, there's also pages are flushed on disk in other occasions, but I mean, as I said, this is simplified view. So this activity of aligning the cache with the disk is important to understand that it happens at checkpoint time. And in this case, we could, for example, monitor or measure random writes. Okay, again, there are also optimization to write sequentially there, but I mean, we already need to measure sequential writes for the WAL. So when the WAL file is completed, what happens is that PostgreSQL marks it as ready to be recycled. Okay, and so it can be used, for example, in crash recovery. So when, for example, in one instance the system is shut down, and that WAL file could be used from the latest to rebuild the consistency of the database from the latest checkpoint. Okay, so all the changes are in the world files. The latest checkpoint is the last known moment in time where the data was flushed from the cache on disk, and by replaying what was in the world files, that's how we achieve consistency. So hopefully, this short overview of the life of a transaction can be useful in the section now, where I'm trying to recommend some architectures for Postgres in Kubernetes. So the major idea here is that it's okay to start benchmarking one instance. Okay, one instance at a time. So that's what we did last time. Okay, so we got one Postgres instance, we benchmark the storage and then the database. Okay, that's okay. So that's important to spot the major bottlenecks. But it's not enough. Okay, once we've done that, the second step is to move to a real life production architecture, which must consider business continuity. Okay, so we need to think how we want to deploy Postgres in production, and in business critical scenarios, we want to have a very high uptime for the database. So, and we need to plan for disaster recovery, which is primarily focused on RPO. RPO is the amount of data we can afford to lose, and high availability, which is primarily focused on the recovery time objective. So after a failure, how long will it take for us to restore the service? Okay. So these are fundamental goals that you need to be aware of before you actually plan a database system or any system, IT system in your infrastructures. Okay, so always think about these two major goals. Okay, and the good thing about Postgres is that it's been designed with this in mind, especially since early 2000, and it's got two fundamental blocks, two fundamental features called continuous backup / point-in-time recovery, because you need backup and then you need to recover. Okay, otherwise, without recovery, backups are useless. Okay, and backups in Postgres are made up of base backups, which is essentially a copy of the pages on disk, plus wall archiving, similarly to what was happening before with crash recovery, starting from a base backup and replaying all the wall files that have been archived in a separate location. We are able to reach a consistency up to a point in time or up to the latest available wall. So that's how you build a database that is resilient to disaster recovery. And always consider that disaster recovery, especially point-in-time recovery, is important when, for example, to prevent from accidental human errors. Okay, for example, the developer that forgot to put a where clause, or the DBA that again did an update without a where condition. Okay, so we need to go back in time before that mistake. And the other feature is streaming replication that is, again, based on the write-ahead log. So you see how important the wall is for Postgres. And when we go to Kubernetes, because these are fundamental blocks, they are kind of primitives, it becomes essential to have Postgres managed by an operator, okay? An operator written by people that know Postgres because of these, or how these internals are created. So building on what I just explained before, so we've got this world file segment that is recycled. We can actually add something in between. When the world file is completed, we can set up Postgres to archive this world file to a separate location on a remote system. That's, in my opinion, the safest approach. So what happens is that Postgres calls the archive command, which is an option you put in Postgres for every wall that can be archived. This is a serialized operation, one at a time. Postgres archives the wall file. When the procedure is completed, the wall file is successfully completed. The wall file is recycled. If the archive command fails, Postgres keeps retrying to archive this wall file. The same wall information, similarly, is used by the so-called wall senders. Wall senders are processes that serve using string replication, the string replication protocol, string replication clients. So string replication clients are the standby servers, usually. Okay, so the replicas. And the archive command usually ships to the so-called wall archive. Both these outlets could become potential bottlenecks in your system. So we need to consider also these two flows. So before we talked about, you know, the sequential writes, so the storage primarily, then we, of course, we've got the memory, CPU, and so on. But we also, in a business continuity scenario, we also need to consider replicas and the wall archive. So here comes my recommended architecture in Kubernetes. So we've got one Kubernetes cluster, or you could see also a namespace, and we've got 3 nodes for Postgres. I'm actually suggesting to have dedicated nodes with dedicated storage, preferably local. And you could also spread these Postgres nodes across 3 different availability zones if they're available. So we've got the primary on the left. The primary is continuously archiving wall files to the remote location known as the wall archive. And then at the same time is streaming to 2 standbys, and both the standbys are part of the option called synchronous standby names in Postgres, so are part of the quorum. So my suggestion is to have at least one of them serve as a synchronous standby, and then as a fallback mechanism, the standbys, in case they fall out of sync or there's a problem with the stream replication connection, they can use the restore command to fetch wall files directly from the wall archive. So these are wall archiving, stream replication, and restore command. These are possible, again, sources of bottlenecks. Again, wall writing, we saw it before, is essentially tied to the local storage and specifically sequential writes, the throughput of sequential writes. And if there is a bottleneck, you basically have a slow database. But also wall archiving can have bottlenecks because, as I said before, in Postgres, this is a serialized process. So only one at a time can be processed by Postgres. If there's problems with the network, you can slow down everything. Also, performance is impacted by the remote storage, how it performs, and so on. And if we are compressing the wall files. And if there's a bottleneck, as I said before, Postgres keeps retrying to archive the same wall files. Wall files can pile up, okay? And they can pile up where the pgwall directory is located. It could be in the same volume where your data files are, or in a separate one. And that can even cause Postgres to halt, okay? Stream replication, again, is affected by the network and this performance of the remote storage of the standbys. Here it depends, the bottlenecks and the issues can depend on whether we have a high value for wall keep segments or wall keep size. So that's the number of walls that PostgreSQL keeps locally on the primary. So beyond this number, beyond this threshold, all these wall files are recycled, and so they disappear. So if the standby needs one of them, it's not available anymore, and the standby falls out of sync. So in order to prevent this from happening, Postgres introduced replication slots. So the primary, or the source, keeps track of the location needed by the standby, the location in the wall, and keeps the wall files needed by each standby. As you can imagine, if there's a problem on the standby, wall files keep accumulating on Postgres, and again, we've got the risk of Postgres halting. Synchronous replication can be used in this case to slow down the primary. So basically, the primary needs to wait for the write to happen also on the standby before commit is returned to the application. However, if you do this, you're sure that the transaction is written on another node. That's also the reason why we recommend not to use one single synchronous standby architecture only. So just with two nodes, and the standby is synchronous, because if there's a problem on this synchronous standby, the only synchronous standby, the primary stops writing. The restore command can also is impacted by the same issues that the wall archiving could have. So the standby essentially can be delayed. And also another source of delay and bottleneck in Postgres is the replay process of the standby. So the standby is in continuous recovery. So it's reading the wall information from either the wall archive through the restore command, or via streaming replication through the wall receiver, and reapplying the wall information, so modifying itself based on what comes from the primary. And this process is limited to one CPU. So in case of high workloads, while the primary, for example, works in parallel, the standby needs to apply the changes in a serialized way, and that can slow down. So that's another recommendation is to have dedicated resources for Postgres, similarly to what we used to do in traditional environments. Also in Kubernetes, if you can dedicate a Kubernetes node to one Postgres instance only. And there's amazing, configuration techniques in Kubernetes, pod affinity, anti-affinity, node selectors, taints, tolerations, and so on. And another advice is to use the guaranteed quality of service for Postgres, which means set requests and limits in the resources of the pod to have the same values, so that we know that that pod will always use the declared resources. Again, if you can, use local storage on the dedicated node so that you can benchmark the throughput. And if you are using public clouds, always watch out for IOPS limitations. And in the end, it's your choice. So it depends on the budget you have and on the cost benefits analysis that you're doing. So again, benchmarking is the activity that gives you the amount of information you need to make decisions on this topic. So what tools did we use? What methodology did we use? Our approach is to observe. Okay, enter this field with with no preconceptions, and try and let yourself be guided by objective numbers and graphs, for example. So we developed these two set of Helm charts. One is called cnp-sandbox and one is CMP Bench. They are both open source under the Apache license. CMP Bench was presented in the last session, and cnp-sandbox is essentially an evaluation platform for Prometheus, Grafana, and our operator called Cloud Native PostgreSQL. So basically, you can test the observability capabilities of Postgres using Prometheus and Grafana. Then we also rely on pgstat statements, which is an extension that is available for PostgreSQL, and that normalizes the queries and gives you metrics, real-time metrics about how queries are performing in your database. However, you can use your own Postgres setup. So you can use your favorite operator, or you can use your container-based installation of Postgres. You don't need also cnp-sandbox. You can use your existing Prometheus, Grafana, or another tool. Okay. So cnp-sandbox essentially deploys a kind of a playground where you can try Prometheus, Grafana, and, as I said, our Cloud Native PostgreSQL. It also ships a selection of PostgreSQL metrics that are built for our Prometheus exporter that is natively available in CMP, and a custom Grafana dashboard that we have developed also thanks to the experience of people that develop pgadmin. The main goals of the sandbox is to play with Postgres, with Prometheus, Grafana, and also use these when you are benchmarking, okay? Because having these diagrams and graphs can help you understanding what happened, for example, in the last 2 days or 3 days, and help you make decisions. My advice is not to run these in production, but use it for pre-production or evaluation. In production, you should use your Prometheus and Grafana installation, and maybe use the metrics and dashboards that are distributed with cnp-sandbox. This is how you can install it. If you do this against an existing Kubernetes cluster, you'll find yourself from a Prometheus and Grafana environment with also the Cloud Native Postgres operator. And this is an example of the dashboard that comes with it. CMP Bench, we have actually improved it from last webinar. And not only we are able to benchmark storage with FIO and pgbench, the database with pgbench, we have also introduced HammerDB. And it can also run against an existing Postgres database. So if you have an existing database installed, for example, with another operator, you can use CMP Bench to monitor that operator. So again, you don't need cnp-sandbox and you don't need the CMP operator. This is how you can, for example, initialize pgbench. So after you run this Helm chart, these are the values, how you can override the values of the Helm chart. I'm running here the initialization script that creates a pgbench database with a scale factor 8,000, which is approximately 130 gigabytes. And this is an example of a run of pgbench that runs for 600 seconds, so 10 minutes, using 64 clients and 128 jobs, and doesn't initialize the database. So basically, you can initialize once and run pgbench with several times with different parameters too. This is, for example, the result of a diagram with higher number of clients benchmarking the database. For example, these are 5 repetitions of a 10-minute pgbench test with scale factor 8,000. We used 3 dedicated nodes on AKS. These are the instances. They have 8 cores and 64 gigabytes, but I set up the guaranteed quality of service with 7 cores and 56 gigabytes of RAM to leave some room also for the Prometheus exporter and the management of the node. And we use premium P80 storage class. There's a synchronous standby, and we were able to reach in this case about 2,500 transactions per second by running pgbench on a separate node. And there's also backup, continuous backup using Azure Blob containers. This is what basically what we saw in what you can see with pgbench and running on cnp-sandbox. An example of transactions. And this is what I wanted to focus now. This is the diagram that shows the wall archiving process. Okay, as you can see, this is something that we don't want to see in production, definitely. And it's pretty much a linear growth of accumulation, in this case, of wall files, because the process is serialized. So Postgres cannot cope with the workload because the archival process is probably slow. Okay, and in this case we got simulated 36,000 walls that had been piled in the meantime. Then we stopped the workload, and as you can see, as I call it, Granpremier della montagna. We got to the peak, to the top, and then now we're slowing down. So in this case, if you are in production here and you've got 36,000 wall files that have piled up and your primary dies, what happens is that those wall files have never been archived. So you've got a hole in the point of recoverability of your cluster. So you've got a missing history of your database in the wall archive. So maybe you've got a standby that comes up, and you can resume there, but you cannot recover in any of these time frame. Okay. So, for example, if you can remediate to this by, for example, parallelizing the archiving process. So in this case, you will still have, some moments where in high workloads, wall files accumulate, but they eventually, come back down. So there could be bulk load operations. And also you can tune the size of the wall file. For example, in this case, I was experimenting 64 megabytes instead of the default 16 megabytes. And this is another example of the graph. I mean, all of these might be okay. Okay, so just don't get scared when you see them, because they might be, again, bulk load operations or vacuums. So you need to learn how to read these kind of graphs. Anyway, there's more. We want to continue working on CMP Bench. So we're planning to improve running multiple tests with increasing number of client connections, and also to manage automatically the repetitions of the test. Otherwise, you have to, write your own bash scripts that collect the data and help you produce those kind of graphs I showed before. We want to support custom pgbench scripts so that you can not only use the OLTP-like benchmark that pgbench produces, but also your own custom queries on your databases, not the pgbench one. We also want to improve support for HammerDB and introduce further tools for benchmarking the database. And we also want to introduce application level benchmarking, which is something we had already done before, for example, myself at second quarantine, where the idea is to introduce web application load simulation with Hey. This allows us also to scale horizontally in terms of front end, so simulate multiple clients, multiple nodes that are targeting the database. So I talked several times about Cloud Native Postgres, and that's the operator that we have developed at HammerDB. The reason why I'm actually showing this slide is that, yeah, I know it's open, it's not open source, it's closed source, and it's currently available for trials. But we're actually planning to open source CMP in 2022. So I'm really happy to declare the intention of HammerDB to do this. It's fully declarative, and it's, you know, a different probably direction we took with our operator is that it doesn't use, for example, stateful sets. We manage our own persistent volumes. It doesn't use an external tool for failover. So we're actually relying on the Kubernetes API server as the source of truth for that. And just to prove that, you know, we believe in database workloads in Kubernetes, I want to say that it's actually the component that manages Postgres in the data layer of Big Animal, and Big Animal is the database as a service delivered by HammerDB. So if you want to run Postgres in the cloud as a service. So in conclusion, why is benchmarking important? Let's not forget that data is the most important asset that an organization has. Okay, and as we are trying to push in this community, that the message must be strong, is that the data can live in Kubernetes, and it's our duty to showcase these scenarios to the world and to actually lead this kind of movement. And that's where we at HammerDB want to be with Postgres. I mean, we are the leaders for Postgres in traditional environments. We want to be the leaders also in Kubernetes. That's our mindset, okay? So don't leave anything to chance, okay? This is important. Before you go to production, benchmark your storage and know the good and the bad aspects of your storage. That's the important thing you need to know. You need to know the limits. You need to know until when you can rely on your storage and when you need to move to a different kind of storage. Same thing with the database. You know, you can plan for an 8-core machine now, and you know that with this machine you can get up to this point, and then it's probably better to move to a 16-core machine with, you know, higher amount of RAM and so on. Okay. Remember, you might not be able to benchmark when you're in production. I've seen this happening for many years. It's too late. It's too late. You cannot test. You cannot benchmark or stress test a production environment. At least, I mean, in some cases you probably can, but the risk is that you put the other services at risk, okay? Because maybe you are using the same environment, same infrastructure, okay? Same network and so on. Especially if in some cases where you're using shared storage, you might, you know, create disruptions for the other tenants. Dedicated storage and dedicated nodes. I won't stop saying this, how important for a database it is to have its own dedicated storage and its own dedicated nodes. That doesn't mean you can't do otherwise. I mean, of course you can use shared resources, shared nodes and shared storage. as long as you've benchmarked and you know your system, you know what to expect. Okay, that's fine. But for a premium kind of database service, it is important to have dedicated resources. Shared nothing architecture is what we'll always promote, because it gives us predictability and performance. Again, first benchmark the single node, then step 2, benchmark the cluster. So in a high availability cluster with continuous backups, replicas, synchronous replicas, understand wall archiving, wall restore, all these processes, how they come into play, observe the system while it's being stressed, okay? And possibly generate chaos in the system by triggering failovers, switchovers. And when you do these, always think about your RPO and RTO posture and goals, okay? They have to be, again, the reasons why you are doing all of this. And finally, I owe everything to Postgres. I owe everything to open source. Study Postgres, especially if you're new, if you're young, and you might be tempted to use for example, other databases because it maybe, Postgres has been around for so long that, cool features have been developed 5 or 10 years ago that they're not promoted, okay, in the last time. Just spend some time on Postgres. I'm sure that you'll find, features you didn't even know that Postgres already had, okay? So yeah, that was it. So thank you for listening, and yeah, Bart, up to you.
Very, very good stuff. Very well-rounded and lots of depth on the explanations. Now we are getting towards the end of 2021, and it's interesting that you're mentioning about, Postgres has a very long lifespan, and perhaps, like you said, maybe that's some younger folks out there like, no, I want the new shiny database that has all these bells and whistles. But what expectations do you have? It's difficult, and we don't expect, you're not a prophet, you're a very intelligent man, but we know it's not your job to know exactly what's going to happen. But if you could predict, do you expect to see a lot more adoption of data on Kubernetes in 2022? What role will Postgres play in that? If we just want to focus more on that specifically, what do you think we can expect to see? More use of operators, further developments in that area? What do you expect?
Well, I definitely expect more adoption. I think, I don't know about Postgres, but I'm actually hoping that, there's more adoption of Kubernetes, Cloud Native. And the good thing about having the database inside Kubernetes is that we can pretty much expand the pipelines. Okay, so one of the major goals of Kubernetes is to create an environment, an organization that is more agile and has a higher pace of development and higher velocity. Okay, so we want to deploy in a faster way and in a very safe, secure, and reliable way. And the best way to do that is through automated testing. So I've seen many times, Kubernetes environments running just stateful sets and the database sits outside, okay? Having the database inside Kubernetes enables to put the database inside the test, part of the test, and have a predictable environment from the developers, a workstation to a staging environment, pre-production environment, and production environments. So I have full control of the whole infrastructure. We are abstracting the infrastructure with Kubernetes, and with immutable containers, we are also able to predict, to reduce the variability on all these environments. So it's a great opportunity we have. So I think we just need to continue hammering on the importance of having the workloads, and our role is to ensure and to deliver this message that it is possible. It cannot be as mature, okay, as it is in bare metal and virtual machines. Of course, we cannot expect the same level of maturity, but I see the gap that is being closed every day, okay, but being shortened every day. So I'm really optimistic about this, okay. So, and I don't know how many people will use Postgres or not. I mean, I hope
quite a few. And there's a very strong community behind it. You know that very well. Having been involved in community work. So I do think there's genuine interest. We had another live stream this week about it. We've got at least another one planned in January. So, it's a topic that attracts a lot of attention. We got a question from the audience, and then we do need to wrap it up. Yeah. Can you talk more about your choice not to use external tools for high availability like Patroni, and instead use a Kubernetes API? And how easy is it or not to use it to prevent splitting brains?
Yeah, okay. So the reason for using that, because Kubernetes, I mean, already has a consensus store etcd, okay? So the information is already there. And we decided basically to just rely on that source of truth. So basically, every instance has in our implementation as an instance manager, which is the PID one of every pod that runs Postgres, and the PID, this instance manager is continuously, talking with the API server in reconciliation loops. So we've seen, it was an idea that the brilliant members of my team had at the start, and we saw that it was possible. So I think that's why we took that approach. And I have to say that, of course, it requires knowledge of the internals of Postgres, but that's what we've been doing for 20 years. And members of my team have been writing all the internals of Postgres from replication to continuous backup and recovery. So we are really, that's what we breathe every day, so we're not scared about that, So we decided to kind of model the information we know, the primitives, how Postgres works with Kubernetes, the Kubernetes engine, basically.
Okay, perfect. Very, very good answer. As usual, folks, if you want to continue the conversation, you can feel free to do so in Slack. Always open to get conversations going there. Can I get you to stop sharing your screen really quickly so I can share mine?
Yeah. The split brain, I forgot to say that, okay. because the the instance managers having one source of truth enables us to have fast control on the shutdown and demotion and promotion procedures of each instance in the cluster.
Okay, very good. Okay, perfect. That being said, this was the last live stream, which sounds crazy for me to say this, because 2021, we've done a lot of live streams. We've had about 65. I think the one that we did the last time with you, actually part one, was live stream around number 49, I believe. So anyway, there's been a lot of stuff going on, and which has been very good. As usual, though, as is tradition, we have our wonderful artist, Angel, who's in the background, creating an artistic depiction of all the things that were talked about. Obviously, there was a lot of stuff. We would probably need 3 or 4 drawings to get it in there. I personally was hoping for a Pink Floyd reference, since you mentioned another brick in the wall, but we'll be sure to get that in LinkedIn and Twitter when we share the post, because that was a very nice reference. Well played. And it's an invitation to the rest of you as well, too. Play around with this stuff. It makes it much more tangible and accessible. We can relate these kind of things together. So anyway, absolute pleasure as always. Looking forward to interacting more next year. Enjoy your holiday as best you can. To everybody out there as well, enjoy your holiday as best you can. Don't worry, next week we do have our Christmas concert. If you would like to play guitar, you are more than invited. If you would like to wait until KubeCon, that's okay too. But I'm
looking forward to Valencia,
Yes, yeah, we all are. It's super close. For me, it's like a 1-hour flight. And so yeah, if we happen to meet up in Valencia, we will definitely be playing music there. I will bring guitars, we'll bring other stuff. Anyway, thank you very much.
Thank you, Bart.
We'll see you
as always.
Absolutely, same thing here for me. Thanks everybody for
Thank you.
attending. Thanks for the questions. We'll keep it going in Slack. Take care, everybody. Bye.